So here we are. We've returned from April break. We're at this sort of midway point in chapter 8. We're actually kind of past midway because we've talked about interior angles and exterior angles. We've talked about parallelograms and everything that's under there. So now it's time to talk about trapezoids. So typically, I'll have my students come up, and the goal is sort of to have somebody just draw a trapezoid from memory because I'm trying to activate some of that prior knowledge. And somebody typically they come up, they go, "You mean like this? Is this a trapezoid, Mr. Card?" I go, "Yeah, I actually just did a terrible job. Let me do that again. That's already a lot better." So, okay, sure. I give them a Jolly Rancher. They sit down. I go, "Okay, that's great. How'd you know that?" "Oh, well, I've seen it before. We talked about that when I was in like middle school." Okay. Well, how'd you know that that is different from the parallelogram type shapes that we've been doing? And I'm recording this after I taught the lesson today. I was very impressed. I was very proud. In all three classes, I had someone go, "Well, parallelograms, Mr. Card, you got two. You got two pairs, parallel sides. But on the trapezoid, it's just the one." So I was very proud of my students today, already being able to sort of figure that out. So here's our big definition. Trapezoid is a quadrilateral with exactly one pair of parallel sides. We call those parallel sides the bases. So I had a great kick today out of saying it's the most based shape that we talk about because there's not just one base, there's two. So that means it's extra based. All right. It's also got two legs, which hopefully you're thinking, geez, that makes me think of other shapes. Well, yeah, we'll get to that in a bit. So the sides that are parallel are the bases. The sides that are not parallel are the legs. All right. So a little refresher, what's it mean to be parallel? That means never intersect. If you never intersect, well then you need to have the same slope. So if I ask you to try and identify, hey, is this a parallelogram or is it a trapezoid, like I would on a shape like this, I'd expect you to be able to say, well, I can use rise over run to figure out that this has a slope of up 1 over 2, so that's 1 over 2. And this goes up 1 over 2, up 1 over 2. So clearly, that's one side, whereas this has a slope of down 1 over 1, down 1 over 1. So that's a slope of negative 1. This is a straight line, which as we know is an undefinable slope. So only one pair of those sides is actually parallel. So here's our favorite type of trapezoid, the isosceles trapezoid. Isosceles, hopefully you're going, I've seen that word before. Yeah, like an isosceles triangle where the two legs are the same. So on an isosceles triangle, you had a base and two legs where the legs were the same and the base angles were congruent. Well, guess what? Here we have an isosceles trapezoid. Legs are the same, and what we're going to learn is the base angles are congruent. Right? Base angles here, base angles here. So we have here, that's the theorem we just went over, and then there's the converse, which sort of says, okay, if it's isosceles, then the base angles are congruent. Well, in reverse, if the base angles are congruent, it must be isosceles. And then we have a trapezoid is isosceles if and only if diagonals are congruent. So the diagonals will be the same, but very important, they will not bisect each other, which you can kind of see, right? Like they don't actually split each other into even pieces, but they are the same as each other. The last thing we need to talk about is a midsegment, which again is something we've actually covered before. Midsegment connects the two midpoints. And I have us do this activity where I sort of have everyone like make a coordinate plane, find some points that make a trapezoid, and then I ask you to use that midpoint formula, find the midpoints, connect them with a midsegment, and use a ruler to figure out how big is x, y, and z, and to sort of compare and see if you can come to a conclusion about how we could calculate the midsegment. I always say, it's kind of related to the idea of a midpoint. It's finding the average. It's finding the average. I honestly despise the fact that they have you write this. I'll call this base 1. Call this base 2. They want you to see it as 1/2 of b1 plus b2. I think it's better to think of it as b1 plus b2 over 2. It's the same thing, but that, I think, makes you realize that what we're going for is the mid-segment is the average of the bases. It's the average of the bases. So when you look at a problem like this, you should be able to say, oh, okay, well, 12 plus 28 is 40 divided by 2 is 20. So that's all the stuff we've covered for trapezoids. We only have one shape left to cover, and that's kites, and then we are done with this chapter. So there's a short little sheet. I've already made the answer key for it, and I'll be updating that assignment in the classroom to have it, but hopefully this video helps, and I'll see you soon.